Hi students, hope you all are doing fine. So your board examination dates are about to be announced. So let's all gear up. In my last video, I have done exercise 5.1 till question 17. So in this video, I'll be finishing off this particular exercise. So let's start with question 18. Okay, so this question says that we have to check the value of lambda for which this function is continuous at x equals to 0. So what you have to do, first of all, you have to check the continuity of this function at x equals to 0, and then we can equate the left hand limit and the right hand limit if it is continuous for finding out the value of lambda. So let us check the continuity of fx at x equals to 0. Let's start with the left hand limit. Limit x tending to 0 minus value of the function is lambda x square minus 2x. Limit h tending to 0 lambda 0 minus h whole square minus 2 into 0 minus h. So when you put here, this is 0, this is 0, so everything is 0, 0 into lambda. So this whole function left hand limit is 0. Now let's go with the right hand limit. Limit x tending to 0 plus function is 4x plus 1. Limit h tending to 0, 4 into 0 plus h plus 1. When I put the value 0, so 4 into 0, 0, I will be getting the value of this function as right hand limit as 1. So left hand limit is not equals to right hand limit. So for none of the values of lambda, this function can be said it is continuous at x equals to x equals to 0. So it is discontinuous at x equals to 0 for any value of lambda. So that way you can write that this function is discontinuous at x equals to 0 for any value of lambda. So the next part, what does it say? Next part of the question, they want it we have to find out whether this function is continuous at x equals to 1. So let's check the continuity at x equals to 1. The function is for x greater than 0, the function is defined as 4x plus 1. So at x equals to 1, x tending to 1, the function is 4x plus 1. So it will be 5, and let's check the function at value of the function at x equals to 1. So again it is 5. So since your limit x tending to 1 fx is equals to f1, so therefore fx is continuous at x equals to 1, but the function is discontinuous at x equals to 0 irrespective of the value of lambda. Lambda may assume any value, but this function is discontinuous because your left hand limit and the right hand limit, they are not equal. Now let's move on to question 19. Question 19 says that gx is x minus greatest integer function x. So we have learned this greatest integer function in class 11. So that is this function, if you remember it, what this function does, it takes greatest integer less than or equal to that particular value of that x. So it is given to us that we have to prove that this is discontinuous at all the integral values. So we have to prove that this particular gx is discontinuous at all integral values. So let's start with this. So let us take any arbitrary integer, that is let c be any arbitrary integer. And now let us check the value of this function is continuous or not at this particular value. So let us check the continuity of gx at x equals to c. Let's start with left hand limit. Limit x tending to c minus limit h tending to 0, and your all the x will be replaced with c minus h. Now before putting the limit, we have to work out this particular thing. For example, let me take a value of c. So for example, let me take c as 1. Okay. So 1 minus h, as h is a very small quantity. So if I subtract 1 minus h, I'll be getting 0 point something. So the greatest integer less than 0 point something will be 0. So what I get a 1 less than the particular value of that integer. So c minus h will be c minus 1. I'll be getting this. So before putting the limit, just work this out. Now you can put the limit. When I put c h equals to 0, this and this gets cancelled out. We are left with 1. Okay, fine. Similarly, we'll go with the right hand side of the limit. X tending to c plus. Again, we have to evaluate the value of this at c plus h. So again, if I take the value of c as 1 and I add something with 1, so it will be 1 point something, and the greatest integer less than that particular integer will be c, that is 1 itself. So after solving this, we will be getting this as c itself. So let's substitute this value and solve it. So when I put the value h0, I'll be getting c minus c, value is 0. So you can see that left hand limit is 1, whereas the right hand limit is 0. So they are not equal to each other. So therefore the function is, since left hand limit is not equals to right hand limit, therefore gx is discontinuous at c, hence discontinuous at all the integral values, because c is an integer. So since this is discontinuous at c, so therefore it will be discontinuous at all the integral values. So question 20, it says that fx is x square minus sin x plus 5. Now we have to check the continuity of this function at x equals to pi. This is a quadratic polynomial, this is the sine function which is continuous, this is a constant polynomial. So all in all these are continuous functions. Addition and subtraction of continuous functions, we know that they are continuous. So we can, just by looking at this question, we can say that this is continuous, but let's anyhow check it at x equals to pi. So let us check the continuity at x equals to pi. There is no point in going for the right hand and the left hand limit because they are obviously going to be the same. So we will be just be putting limit x tending to pi fx, which will be limit x tending to, let us put the limit right away. So it will be pi square minus sine pi plus 5. Now we know that the value of sine pi is 0. So that makes pi square plus 5. Now let us find the value of the function at pi. Again this will be pi square plus 5. Since limit x tending to pi fx is equals to f pi, therefore fx is continuous at x equals to pi. So question 21. In this question, it is required for us to prove that sin x plus cos x, sin x minus cos x, sin x into cos x, they are all continuous. So for such type of questions, and even for question 22 also, we can just follow this pattern only. We can prove that sin x is continuous, we can prove cos x is continuous, and then we know that algebra of continuous functions. So we'll be using that particular concept here and prove that all the functions are continuous. So let's start with proving that sin x is continuous. So let us take hx as sin x. Let us check the continuity of this function at C, any arbitrary real number. Let's check the continuity of hx at C, any arbitrary real number. Limit x tending to C minus when you put this zeros, it will be sin h. Right hand limit will be x tending to C plus you can even expand this using this formula, h tending to 0 sin of C plus h. I can expand this using the formula sin C cos h plus cos C sin h, and it will be limit h tending to 0. So this particular thing will be 1 and this will be 0. So you will be getting this sin C. Similarly, you can do the same thing here also. Okay. So limit h tending to 0, sin C cos h minus cos C sin h. So after putting the limit, you will be getting sin C. So your left hand limit, right hand limit, they are all equal, and I'll find the value of the function at x at C. So you can see that left hand limit is equals to right hand limit is equals to the value of the function at C. Therefore, this function is defined, is continuous at x equals to C, where C is any arbitrary real number. So therefore, hx is continuous at x equals to C. Similarly, we will do the same process for cos x. So let us take px as cos x. So again, let's check the continuity. At x equals to b, any arbitrary real number. So left hand limit will be limit x tending to b minus cos x. इसमें भी आप फॉर्मूला डाल दीजिएगा, cos of b minus h. So that will be limit h tending to 0 cos b cos h plus sin b sin h. When you put the limits, If this function, this will be 1 and this will be 0. So you will be getting cos b. Right hand limit x tending to b plus cos x. So it will be cos of b plus h. Let's put that formula. Cos b cos h minus sin b sin h. Again, this value will be 1, this will be 0. So we'll be getting this as cos b. So therefore you can see that left hand and right hand limit both are same. We'll find the value of the function at fc. So we can see that right hand, left hand and the value of the function at x equals to c, they are all same. Therefore px is continuous at x equals to c. So that solves our I have taken it as b. Okay, so I'll be putting here b. Fine. So that gives us sine and cos both are continuous at all real numbers. So now I'll be using this particular thing and then proving that sin x plus cos x, sin x minus cos x and sin x into cos x, even sin x divided by cos x, these are all continuous. Now we have proved that sin x and cos x are continuous function. So since sin x and cos x are continuous function at x equals to c, therefore what I can write, that their sum is also a continuous function. Therefore sin x plus cos x is a continuous function. Similarly, this is the first part. Similarly, for the second part also I can write, therefore sin x minus cos x is a continuous function. And for third part also I can write sin x into cos x is a continuous function according to the law of according to the algebra of continuous functions. So I have used this for proving this because sin x and cos x, both are continuous functions. Now we can use the same concept for moving on to question 22 as well. 22 में हमें क्या प्रूफ करना है? इसी के आगे हम इसे को भी प्रूफ कर सकते हैं. बाकी सारे साइन और कॉस हमने कर लिए. अब बाकी सारे आपको यदि प्रूफ करने हैं, सीकेंट, कॉट, कोजेक, ये सारा हम टैन भी कर सकते हैं. तो जो चीज़ें दे रखी हैं वो तो दे कर ही सकते हैं, इसके अलावा बाकी चीज़ें भी कर देते हैं. सो इट इज़ व्हाट इज कोजेक? Cosec is 1 by sine. This is a polynomial, constant polynomial, and sin x we just have proved that this is a continuous function. So दोनों का fx by gx will be a continuous function. तो आप क्या लिख सकते हैं? Since fx equals to 1 is a constant polynomial, hence continuous, and gx equals to sin x is a continuous function. ये हमने पहले ही प्रूफ कर दिया है, इसे आप यहाँ पे प्रूफ कर दीजिएगा दोबारा. इस क्वेश्चन को यदि आपको पूछा जाए कि कोजेक एक्स आपको कंटिन्यूस प्रूफ करना है तो साइन एक्स को आप कंटिन्यूस प्रूफ कर दीजिए. सो दोनों कंटिन्यूस फंक्शन है तो हम क्या लिख सकते हैं? देयरफॉर f by g is also a continuous function and it is continuous at c, any arbitrary real number. फाइन, कोजेक को प्रूफ कर दिया. अब ऐसे ही करके आप सेक को प्रूफ कर सकते हैं. सेकेंड चीज, यदि हमें सेक को प्रूफ करना है सो इट इज 1 by cos x. सिमिलरली यू कैन राइट दिस, सिंस fx equals to 1 is a constant polynomial, हेंस कंटिन्यूस हो गया, एंड cos x इज अ कंटिन्यूस फंक्शन, अभी हमने प्रूव किया। देयरफॉर f by g is also a continuous function at x equals to c. Fine. Similarly, you can go for cot. Cot will be sin, sorry, cos by sin हो जाएगा, tan will be sin by cos. इन सबको आप continuous proof कर सकते हैं f by g. Similar method से आप just you have to write it, sin x is continuous, cos x is continuous, and therefore their division, that is f by g, will also be continuous. हाँ, one thing you have to make sure that it should be defined at that particular point. So जिस जगह पे denominator 0 आ रहा है उस point पे आप उसको define भी नहीं कर सकते, इसलिए उस point पे वो continuous भी नहीं होगा. In question 23rd, there is a function fx is sin x by x for x less than 0 and x plus 1 for x greater than or equals to 0. In this particular question, we have to check all the points of discontinuity. You can see that this function sin x is a continuous function, this is a polynomial function, so this in itself will be a continuous function. So for x less than 0, this will be a continuous function. This is again a polynomial function, so for x greater than 0, this will be a continuous function. But for x equals to 0, we have to check whether the left hand limit and the right hand limit is equal or not. So we just have to write down all those details. So what you will write, since sin x and x are continuous functions, therefore sin x by x is continuous for x less than 0. So this function fx is continuous for x less than 0, and x plus 1 being a polynomial function is also continuous for x greater than 0. So let's check the continuity at x equals to 0. So we have ruled out all the possible points of discontinuity, only we have to check down at this particular point, that is at x equals to 0. So we'll start with the left hand limit, then we'll go to the right hand and so on. So left hand limit x tending to 0 minus function is sin x by x, limit h tending to 0 sin of 0 minus h divided by minus h. This particular part will be minus h, which will be equals to minus sin h divided by minus h. They cancel out each other. We already know the formulas, limit extending to 0, sin x by x is 1. So we will be using that particular thing and our answer will be 1. So let us check out for the right hand limit x tending to 0 plus, function will be x plus 1 since your right hand and left hand limit both are equal, so the value of the function at 0 is also 1. So you can say that left hand limit is equals to right hand limit is equals to f0. Therefore, fx is continuous at x equals to 0, and we have already proved that it is continuous at all other points. So therefore, fx is continuous everywhere. Fine. So now moving on to question 24th, we have to check that this function is continuous or we have to check whether this function is continuous or not. So fx is x square sine of 1 by x for x not equals to 0, and for this it is 0. So we know that this function it can be discontinuous at x equals to 0. So let us check the continuity of this function at x equals to 0, because at all other points x square into this function is continuous, this function is continuous. So the product of these two functions will be continuous. It will be undefined at x equals to 0. So x is not equals to 0. So this function is continuous throughout its domain, and this is 0. This is a constant polynomial. Again, it is a constant. It is a continuous function. So therefore, these two functions are continuous in itself, but we have to check the continuity at x equals to 0. So let us check the continuity of fx at x equals to 0, and it is continuous at all other points. Fine. So let's check at x equals to 0, left hand limit will be limit x tending to 0 minus x square sine of 1 by x. H tending to 0, 0 minus h whole square sine of 1 by. When we square it, it will be h square, and this function यहाँ पे minus बाहर आ जाएगा. So I can write as minus h square sine of 1 by h. Now you can see that the value of this will be sine of 1 by 0. Now according to the Sandwich Theorem, what does it says? That the value of sine x lies between minus 1 to plus 1. So we have to find out that in between this particular, if I put the value of this 0, so I can say that sine of 1 by 0 will lie between minus 1 and plus 1, and the value of this particular thing is 0. So what can you write about this? 0 into value of this particular thing lies between minus 1 and plus 1. So 0 multiplied by anything will be 0. So that way we got this answer. This particular thing is, we have deduced it from the Sandwich Theorem, that this value lies between minus 1 and plus 1. Similarly, we can go the same thing with the RHN. Limit x tending to 0 plus so we'll be getting the value as h square into 1 by h. h square की value 0, again इसकी value same, value lies between minus 1 to plus 1. 0 multiplied by anything, you will get this as 0, and the value of the function at 0 is given as 0. So I can say that left hand limit is equals to right hand limit is equals to f0. Therefore fx is continuous at x equals to 0, and hence everywhere. Question 25th, we have to check the continuity of this function. The function is sin x minus cos x for x not equals to 0 and minus 1 for x equals to 0. Now you can see that sin x is continuous, cos x is continuous, so sin x minus cos x definitely will be a continuous function. But we have to check the continuity at x equals to 0. So let's jot it down. Since sin x and cos x are continuous functions, therefore fx, which is sin x minus cos x, is continuous for x greater than 0 and x less than 0. So now let us check the continuity at x equals to 0. So let's start with left hand limit, limit x tending to 0 minus sin x minus cos x now this will be sign of minus h, this minus sign. Obviously you can take it out, so this will be minus sin h, and this will be cos of minus h, as we know, is equals to cos h. Let's put the limit 0 0 here. Sin 0 is 0, cos 0 is 1, so this will be minus 1. Similarly, you can go for the right hand limit. 0 plus sin of 0 plus h minus cos of 0 plus h. So it will turn out to be sin h minus cos h. Now same thing will be there. 0 is 0, this is 1. So this is minus 1. So you can see left hand and right hand are equal, and this is also equal. So since your left hand limit is equals to right hand limit is equals to f0, therefore fx is continuous at x equals to 0 and hence everywhere. Okay. Now in the next 4 questions we have to find the value of k, and it is given to us that the function is continuous at that indicated point, that is at x equals to pi by 2 in this particular question. So we need to find the value of k if the function is continuous at x equals to pi by 2. So since the function is continuous, so left hand limit will be equals to right hand limit. So since fx is continuous at x equals to pi by 2, therefore left hand limit will be equals to right hand limit at x equals to pi by 2. So let's find out the left hand and the right hand limit and then equate both of them. Pi by 2 minus k cos x divided by pi minus 2x. Limit h tending to 0, and we will be writing pi by 2 minus h in place of x. So you can see that cos of 90 minus theta is sin theta. So let's use that. Let me write it here itself. So limit h tending to 0 k, it will be, sorry, अभी मैंने आपको क्या बताया, cos की जगह हम क्या लिख देंगे, sin h लिख देंगे, and this denominator, simplify this, okay. So this will be minus pi, this pi and this pi will cancel out, and this will be plus 2h. So denominator will be 2h. Now k and 2, they are independent, so I can take them out of the limit part. So limit किस में लगा देंगे, sin h by h में. As we already know, sin h by h is 1. So the left hand limit will be equals to k by 2. Now the right hand limit part, इसमें तो ये एक कांस्टेंट फंक्शन है 3, सो इसकी वैल्यू क्या आ जाएगी 3. So since left hand limit is equals to right hand limit, therefore मैं क्या लिख सकती हूँ, k by 2 will be equals to 3, so k की वैल्यू हो गई 6. In question 27, it is given to us that this function is continuous at x equals to 2. So need to find out the left hand limit and the right hand limit. You need to find the value of k. So we'll be equating that. So at x equals to 2, let's find out the left hand limit. Limit x tending to 2 minus kx square. This will be h tending to 0. ज़ीरो हो गया, ये 4h 4k आ जाएगा इसका. राइट हैंड लिमिट इट इज अ कांस्टेंट, सो द आंसर इज 3. Since fx is continuous at x equals to 2, therefore left hand limit will be equals to right hand limit at x equals to 2. So I can write 4k will be equals to 3. So k की वैल्यू आ गई 3/4. Question 28, we have to do the same thing as we have done in the last two questions. We need to find the value of k, and it is given to us that the function is continuous at x equals to pi. So let's check the left hand limit and the right hand limit. So at x equals to pi, the left hand limit will be limit x tending to pi minus function is kx plus 1, limit h tending to 0, pi minus h, and when you put this as 0 it will be k pi plus 1. Now let's move to the right hand limit. Limit x tending to pi plus function is cos x, so it will be limit h tending to 0 cos of x plus pi plus h. h 0 हो जाएगा तो cos pi की वैल्यू होगी -1. Now since it is given to us that fx is continuous at x equals to pi, therefore we can write left hand limit will be equals to right hand limit at x equals to pi. So our k pi plus 1 will be equals to -1, so k pi will be -2, k will be -2 by pi. So this is the value of k we got for question 28. So the last one in the series, 29th, we again need to find the value of k at, and the function is continuous at x equals to 5. So let us check the left hand limit and the right hand limit at x equals to 5. h tending to 0, 5 minus h plus 1, 0 कर देंगे तो 5k plus 1 हो जाएगा. राइट हैंड लिमिट विल बी x टेंडिंग टू 5 plus 3x minus 5. So if I put the limit as h tending to 0, 3 into 5 plus h minus 5, 15 minus 5, 10. So right hand limit, left hand limit आ गया. Now since the function fx is continuous at x equals to 5, therefore you can say that the left hand limit and the right hand limit will be equal at x equals to 5. So I can write 5k plus 1 equals to 10. So k will be 9/5. So this is the answer we got for question 29th. So let's now move on to question 38. 38 में क्या करना है, fx की वैल्यू ये दे रखी है और ये बताया गया, it is given to us that the function is a continuous function. So we need to find the value of a and b here. So since we know that the function is continuous, so it will be continuous at 2 as well as at 10. So let's first work out with 2. So left hand limit will be equals to right hand limit for x equals to 2, and similarly for x equals to 10, again the left hand limit will be equals to right hand limit. So in that way we will be getting two particular equations, and if after solving that, two variables, two equations, we can solve it. So at x equals to 2, let's go for the left hand limit. It is a constant function, so definitely it is going to be a x2 पे ये 5 हो जाएगी इसकी वैल्यू लेफ्ट हैंड की, और राइट हैंड की x2 प्लस पे ax प्लस b. तो लिमिट x की जगह आप डाल देंगे 2 प्लस h, 0 हो गई, 2a प्लस b आ गया इसकी वैल्यू. अच्छा, हमें पता है कि सिंस fx इज कंटिन्यूस एट x इक्वल्स टू 2, therefore left hand limit will be equals to right hand limit, therefore 2a plus b will be equals to 5. This is the first equation. We can take the value of b from here as well, b minus 2a. Now let's check the continuity at x equals to 10, left hand and the right hand limit. Limit x tending to 10 minus ax plus b, limit h tending to 0, a into 10 minus h plus b, and it will be 10a plus b, and the right hand limit, it is a constant polynomial, so it will be 21. So we know that fx is continuous at x equals to 10. So left hand limit will be equals to right hand limit, and this is 10a plus b. A was missing there, so 10a plus b equals to 21. So I got the value of b as 21 minus 10a. Equation 2, from 1 and 2 I can immediately get the value of a. From 1 and 2, it was 5 minus 2a, and it was 21 minus 10a. So this will be 8a and this will be 16, so a will be 2, and if I put a as 2, b will be 1. So we got the value of a and b, a as 2 and b as 1 in question 38th. Now the next three questions, that is 31st to 33rd, these are based on the concept of composition functions, which you have learned that if two functions are continuous, then their composition will also be a continuous function. So similarly, cos of x square, you can see that this is the composition between cos x and x square, and since both are, cos x is a continuous function, x square is a continuous function, so their composition will also be a continuous function. So let हम assume कर लेते हैं gx is equals to cos x and hx is equals to x square. Now let us find composition of GOH. So g of hx is x square, so इसकी जगह आप लिख देंगे cos of x square. Since gx and hx both are continuous functions, hence fx, which is equals to composition of these two function is also a continuous function. Similarly, we can go with same way in 32nd question. This is fx is equals to cos of x absolute value of this. So what can I do? Similarly, I can use the same concept here. Gx is absolute value of x, hx is cos x. Now let us find GOHX, composition of these two. So G of cos x, so this will be cos x. Now since again these two functions are also continuous, this is a modulus function is a continuous function and cos x is a continuous function. So therefore their composition will also be continuous. Hence fx will also be a continuous function. Okay. So question 33rd, same pattern. Fx is a composition of two functions, that is sin x and absolute value of x, and both are continuous functions. So their composition will also be a continuous function. So we'll say hx is equals to sin x and gx is absolute value of x. HOGX will be h of gx, which is this, and this will be sine of absolute value x. So since you will write that hx and gx both are continuous functions and therefore their composition will also be continuous. Continuous functions, and therefore fx, which is equals to the composition of HOG, is also a continuous function. Fourth question. In this question we have to find all the points of discontinuity. The function is fx is absolute value of x minus modulus of x plus 1. So let's redefine this function. कहाँ पे इसको redefine मतलब इस function को यदि मुझे redefine करना हो तो किस तरह से हम start कर सकते हैं? Point of discontinuity हम कैसे निकाल सकते हैं? I'll give you a trick here. हाँ? जैसे एब्सोल्यूट वैल्यू के अंदर जो होता है उसको ज़ीरो पुट कर दो. जैसे आपने यहाँ पे क्या पुट कर दिया, x की वैल्यू, यहाँ पे x आ रहा है तो यू पुट x एज ज़ीरो, तो x की एक वैल्यू हमें क्या मिली, ज़ीरो मिली. इसके अंदर की चीज़ को भी आप ज़ीरो पुट कर दो तो x की दूसरी क्या वैल्यू मिली, -1. सो हमारा पॉइंट ऑफ डिसकंटिन्यूटी इस पॉइंट पे हो सकता है 0 और -1. सो लेट्स रिडिफाइन द फंक्शन फॉर दीज टू पॉइंट्स लेकर हम फंक्शन को रिडिफाइन करते हैं. ठीक है. सो fx को हम कैसे लिख सकते हैं? सबसे पहले शुरुआत करते हैं फॉर x लेस देन -1. लेस देन -1 होगा, कोई भी वैल्यू नेगेटिव वाली ले लीजिए, -1 से कम, दिस विल बी नेगेटिव. सो टू मेक इट पॉजिटिव व्हाट यू हैव टू डू, यू हैव टू पुट अ नेगेटिव साइन इन फ्रंट ऑफ इट. ठीक है. -1 से कोई भी चीज़ छोटी ले लीजिए, दैट इज -2 ले लीजिए. -2 पुट करते देखिए इसमें भी वैल्यू आपकी नेगेटिव आ रही है एंड मॉड्यूलस साइन हैज़ टू बी पॉजिटिव. सो इसके सामने भी आप नेगेटिव साइन लगा देंगे. एक नेगेटिव साइन ऑलरेडी है, सो दैट विल मेक दिस एज पॉजिटिव. सो सॉल्व करेंगे तो क्या आ जाएगा, इसकी वैल्यू आ गई 1 फॉर x लेस देन -1. अब हम चलेंगे, हमारे पास कौन से दो पॉइंट्स थे, -1 और 0. सो हम -1 और 0 के बीच वाला ले लेते हैं. सो -1 से 0 के बीच में ले लेते हैं इसमें. सो लेट अस टेक 1 पॉइंट एज -1 और 0 के बीच में -0.5. -0.5 नेगेटिव आ रहा है, पॉजिटिव करना है. सो इसमें हम एक नेगेटिव साइन लगा देंगे और इसमें -0.5 पुट करेंगे, बट इसकी वैल्यू पॉजिटिव आ रही है. सो नो नीड टू मेक इट पॉजिटिव. सो ये आ गया. सो x - x -2x हो गया और ये -1 हो गया. फाइन. एंड द लास्ट वन क्या लेंगे हम, फॉर x ग्रेटर देन और इक्वल्स टू 0। तो इसमें x ग्रेटर देन इक्वल्स टू 0 में भी ये पॉजिटिव है और ये भी पॉजिटिव है, सो वी डोंट नीड टू चेंज देयर साइंस। सो विल बी सॉल्विंग इट, विल बी गेटिंग x कट जाएगा, सो दिस विल बी -1। So we have redefined the function. Now we need to check the continuity at -1 and at x equals to 0, because at all other points they are continuous. This is a polynomial function, this is a constant polynomial, so these are continuous functions. So only we need to check the continuity at x equals to -1 and x equals to 0. These 2 points can be the point of discontinuity. So fx is continuous everywhere except we need to check the continuity at x equals to 2 and x equals to -1 and x equals to 0. These 2 points can be the point of discontinuity. So we need to check the continuity at -1 and 0. So let's start with x equals to -1. It will be left hand limit will be limit x tending to -1 minus कांस्टेंट पॉलिनोमियल है, इसकी वैल्यू 1 आ जाएगी। राइट हैंड लिमिट में डालेंगे तो x टेंडिंग टू -1 प्लस इसकी वैल्यू है -2 -1 लिमिट h टेंडिंग टू 0 हो जाएगा। यहाँ पे आप पुट कर देंगे -1 माइनस प्लस h and the value will be 0 हो जाएगा, +2 and -1, so it is going to have 1. So left hand और right hand limit दोनों equal है और इसकी वैल्यू हम f-1 पे भी निकाल के देख लेते हैं। It is again 1. So since the function is left hand limit is equals to right hand limit is equals to f-1, therefore fx is continuous at x equals to -1. Now we have to check the continuity at x equals to 0. So let's start with left hand limit. Left hand limit will be limit x tending to 0 minus -2x -1 limit h tending to 0 and x will be replaced by 0 minus h. 0 पुट कर देंगे तो वैल्यू आ जाएगी -1 एंड राइट हैंड लिमिट, ये तो कांस्टेंट पॉलिनोमियल है तो इसकी वैल्यू तो आ ही गई। कहाँ पे थी, 0 प्लस पे करना था, सो इट वाज -1 एंड f0 की वैल्यू -1 है। तो सिंस योर लेफ्ट हैंड लिमिट इज इक्वल्स टू राइट हैंड लिमिट इज इक्वल्स टू f0, देयरफॉर द फंक्शन fx इज कंटिन्यूअस एट x equals to 0 and the function was continuous at all other points. It was continuous at x equals to -1 and it is continuous at x equals to 0. Therefore the function will be continuous at all other points we have already discussed. So the function makes us function is a continuous function throughout. So students, with that we finish the exercise 5.1. होप आप लोगों को सारे कॉन्सेप्ट्स क्लियर हुए हैं, बिकॉज दिस चैप्टर इज़ वेरी वेरी इंपॉर्टेंट फ्रॉम द एग्जामिनेशन पॉइंट ऑफ व्यू। कंटिन्यूटी से एक ना एक क्वेश्चन ज़रूर आएगा, सो गो थ्रू दिस लेक्चर केयरफुली। सो स्टूडेंट्स, प्लीज़ लाइक, शेयर एंड सब्सक्राइब। थैंक यू सो मच।